Compute the integral of secant to the fourth x times tangent to the fourth x dx. Now let's prep this. This is really the indefinite integral of the quantity secant of x raised to the fourth times the quantity tangent of x raised to the fourth power. Since this is a product integral and there's not really any chance of expansion, let's try a u substitution. Now there's two things in parentheses here, sine x and tangent x. And there's not really any way to distinguish between the two of them, so let's just try letting u be secant of x and see what happens. If we differentiate, we get du dx is equal to the secant of x times the tangent of x, and we can multiply both sides by dx to get this differential. Does it fit? Well, yeah, there's plenty of secants and tangents to go around. Let's make this more obvious. Let me pull a secant x, tangent x, dx off to the side right here. And that means we're going to have a secant of x quantity cubed left over and a tangent of x quantity cubed left over. So the differential does fit. Let's replace it with du. And we can also replace the secant by u to have a u cubed. But what about this tangent of x left over here? Well, remember that the tangent of x quantity squared plus 1 is the secant of x quantity squared. This is the other Pythagorean theorem. This says, in particular, that the tangent of x is the square root of the secant of x squared minus 1. So when we raise it to the third power, this is the same thing as the secant of x quantity squared to the 3/2 power. And now we can replace this with u squared minus 1 to the 3/2 power. And so this would become the integral we'd have to work with. The integral of u cubed times u squared minus 1 to the 3/2 power du. This new integral is a product, and it's going to require a substitution because of that 3/2 power. So this might not be the easiest way to go. However, remember, we had two choices for a substitution, secant or tangent. Let's go and try the other substitution and see if it's any easier. It doesn't take that much time to check it. If we let u be the tangent of x, let's actually move this over here so we have some space. If you use the tangent of x, then the derivative is going to be secant of x quantity squared. So we can multiply both sides by dx and have this differential. Does it fit? Well, yeah, we got lots of secants here. So let's see, if we pull a secant of x quantity squared out to the side for the differential, that's still going to leave us with a secant of x squared right here. And we have the tangent of x raised to the fourth power, who we haven't touched yet. So the differential does fit. We can replace this term with du. We can also replace those tangents with u's, so we'll have a u to the fourth right here. And now we've got to deal with the secant bit. Well, remember that the secant squared is 1 plus the tangent of x squared by the Pythagorean identity again. And so we can replace this bit by 1 plus, oops, I put that's 2 on the wrong side right here. Sorry, this is 1 plus the tangent squared. I said it right, wrote it wrong. So we can replace this with 1 plus u squared. And this becomes our new integral. Cleaning it up, this is the integral of u to the fourth times 1 plus u squared du. It's another product integral, but this one can be expanded through. And that usually means it's an easier integral. So let's stick with this one. So let's continue on our work with this orange integral. If we expand, distribute through, we're going to have u to the fourth plus u to the sixth power du. Both of these are simple power functions. We'll have the first guy integrates to 1/5 u to the 5. The second guy integrates to 1/7 u to the 7th. And if we back substitute, we get 1/5 u, which is tangent of x, that was the one that worked, to the 5th power, plus 1/7 the tangent of x to the 7th power. And again, we can pull out a tangent of x to the 5th from both pieces, and also a 1/35th, and we'll be left with a 7 in the first term, plus a 5 tangent squared in the second term. There's one antiderivative, and now here's every antiderivative. And so we have the answer. You could have also left the previous line with a plus c, and that would have worked fine too.